So it says show this by integrating 1 plus x to the n. So let's integrate 1 plus x to the n the easy way first. So 1 plus x to the n, to the n with respect to x would get us 1 plus x to the power of raise the power by 1, divide by that power. Now, you can see by looking at this answer, when we integrate, we actually want a definite integral, not an indefinite integral. So what am I going between? I want a 2 to the n plus 1, so you can see that would come by subbing in x equals 1. And the other term's just a 1, so I'm going to sub in a 0. So I'm just going to use that knowledge to change that to a definite integral between 0 and 1. So again, when I sub 1 in, I get 2 to the power of n minus 1, sorry, n plus 1, minus when I sub 0 in, I get 1 plus 0, so that's just 1 to the whatever power, still 1, all on n plus 1. So when I integrate the 1 plus x to the n in that format, that's what I get. What about the other side of that? Well, when I integrate 1 plus x to the n expanded, I should get the other side. So remember, expanded gives you n choose 0, n choose 1x, n choose 2, x squared. Now we could do this a number of different ways, as in we could write it as a sum, or you could just say, all right, that equals that. Now, when I integrate the left-hand side, so you could say this is my integral of my left-hand side. If I now integrate the right-hand side, so if I integrate 1 plus x to the n with respect to x, but do it this way, then I'm going to think that that's just a constant, so now it becomes n choose 0x. This one will be n choose 1, x squared on 2, so I write on 2 out the front. Next one will become n choose 2, it'll be x squared goes x cubed on 3, so 3. And we'd keep going until we get to our n choose n1, which is x to the n, so that would be x to the n plus 1 on n plus 1. So that's what we're going to get there. Now you can see I did it that way rather than write the sum. Okay, so and I haven't finished because look at what we're trying to get. So I just want it to look the same way, but we could have done the sum inside the integral. Now, this, remember, we're doing between 0 and 1, so I want that definite, otherwise I would have put plus c. Now, when I put in 1, you can see we're going to get n choose 0 times 1. Then we're going to get half n choose 1 times 1 squared, a third n choose 2 times 1 cubed, etc., all the way up to 1 on n plus 1, n choose n, and then 1 to the power of blah blah n plus 1. And then we're going to go minus. Now when we sub 0 in, 0, 0, we're going to get all zeros, yes? So we're going to end up with just this nice left-hand side of what we're trying to prove. So then we can say, oh, have a look at that. So that equals that. Okay, hope that helped.